All right, so this is going to be the first of a few videos looking at flow control. And I say a few videos, I'm just going to break this up because I think it could run a little bit long. So there might be 2 videos or might be 3, just depending on how quickly we are getting through this material. But this is very important because a lot of times when we're writing program, we need logic in place that allows us to kind of control the path that the program takes, depending on situations that arise when we're essentially solving the problem that we are trying to write the code for. So I'm going to go through a lot of different techniques for flow control. A lot of these are kind of standard. We see them in a lot of languages, things like for loops, if statements, while loops. But there are some Python specific things that I do want to cover in particular that have kind of emerged in some recent versions, such as the walrus operator, and then how we iterate through dictionaries and whatnot. All right, so let's go ahead and get started. And the first thing that we're going to look at are for loops. All right, so a for loop is a very common flow control mechanism that we use to essentially iterate over a set of items. Right, so in Python, we have a lot of different containers that we could wish to loop over. These include lists, sets, dictionaries, just to name a few. So we might use a for loop for this purpose. So I'm just going to show you kind of the very, maybe the first for loop that everybody kind of sees when they're looking at Python demonstrations. And that's typically something like this. So I'm going to say for number in range. And I'm going to do 11. And then I am going to print the number. All right, now this is a very, very simple loop, but there's a lot of things going on, a lot of things to kind of unpack here. So the first thing that we'll kind of notice is the for loop begins with this for keyword, right? So we see we've got for number in range. Now, if you think about this, so this is a blank Jupyter notebook, and so just pull it up. Nothing has been ran at this point. So the first thing that you might ask is, well, you haven't defined number anywhere in this code, right? This is a brand new notebook. So we're saying for number, and we haven't declared that as a variable anywhere else in our code. And then we've got this range here, right? So this range statement. So I'm saying for number in range, and then I'm going to print whatever that number is. Let's just run this real quick, and then we'll kind of unpack and explain all those little pieces. All right, so you'll see that what this actually is doing is this is printing essentially, just a stream of integers to the screen, starting at 0 and going all the way up to 10. All right, so let's go and kind of really unpack what's going on at each step of this. So first thing, let's talk about this range object. All right, so if I were to do range, first off, if I were to just, get the type of this, let's see what the type of the range object is. All right, so it just returns a type. All right, so apparently range is a type itself. And let's go to this range. It's actually a function. So I guess it returns back that it is an actual type because it's a very specific type of object, and you kind of use it like a function in Python. But with range, what you can do is you can give it a stopping number, so it takes an integer as an argument, or you can give it a start, a stop, and an optional step parameter. All right, and what it does, it returns an object that produces a sequence of integers from start, and it includes that start, if we specify that, to stop, and it excludes the stop value. Okay, so the start value, if you don't provide it, so if you use this signature right here, this range, and you just provide a stop, the start parameter is going to default to 0. So that's actually what happened here. So we just provided a stop of 11. So it started at 0, and then it increments up to the value that we specify for stop, but it doesn't include it. Remember, that piece was exclusive, right? So stop is omitted, right? They're really emphasizing that in the documentation. All right, so when we did a range 11, this returns a range object that starts at 0 and it goes all the way up to 11, not including 11. Now, what is going on in this for loop is, since we're saying, okay, well, for number in this range, what it's doing is It's essentially iterating over each one of those items, each one of those integers in that range, from in this case 0 all the way up to 10, and it's storing the current value in that range in each step in a variable called number. So this is your looping variable. So when we're talking about number here, we haven't defined it elsewhere in the code, but it's getting assigned to in each iteration or each step of this for loop. So in the first step, that first integer that range returns is a 0, so that gets inserted into number, and then that's why when we say print number, we get the 0 here. All right, and then the next step in that loop, okay, the next integer that it encounters is going to be the integer 1. Well, that gets stored into number, and it gets printed. All right, so you've got this looping structure, and we're kind of iterating over this range, making steps along that range, each time storing the current value in the variable number and then printing that to the screen. All right, so that's how a for loop will be working. So we've got some object that we can iterate over, and what we're going to do is we're going to save each element in that object in a temporary variable, and then we can do stuff with that temporary variable, right? So we don't have to just print the number. We could print the number and say the number squared, and so forth, right? So we've got, the current value from that range is stored in number, and we can do whatever computations we want with that. All right, so that's just a very basic for loop. Let me do a restart and clear all output. All right, so the key thing is in Python, you can define a for loop, and in this case, we're iterating over a range, but you can iterate over anything that is iterable. So objects in Python will either be iterable or not iterable, right? Just meaning, is this object something that I can iterate over? Can I step over it in this for loop type of fashion? All right, so another object that is very common and is iterable is a list. So I'm just going to define a list here. We'll call it my list. Let's put a few characters in there. So we'll say A, B, C, D. All right, so we've got a list. A list is iterable. So I'm going to define this list. And what we can do is we can say, well, for item in my list. All right, and then we can print that item. All right, so list can be iterated over as such. All right, and then one thing that I want to, just kind of, make you aware of. So right now we're kind of printing things to the screen, but as we iterate over items in a list, a lot of times, some of the examples that we tend to see when people are kind of demonstrating flow control in Python, in any language, because for loops are kind of pretty much seen everywhere as far as programming languages. But one thing that's really unique about Python, a lot of times when we see examples, it's either we're printing characters or we're printing integers or numbers or something like that. But if you recall, when we, there's a video that I've got posted that's talking about lists. Lists are extremely flexible, right? So we can have, it doesn't have to be that everything stored in a list is of the same type. Okay. So we can actually put, mix integers with floats. We can actually put functions in there. Okay. So let's look through this. Let's look at that particular example where we've got maybe functions in here, because I think this can be really powerful sometimes. And I oftentimes have used this either in combination with lists or dictionaries and kind of looping through a set of functions. But let's see what I'm talking about. Let's say that I've got a set of numbers. All right. So 1, 2, 3, 4. All right, and what I'm going to do is I'm going to create a list of functions. So I'm just going to use the built-in functions. All right, and I'll show you what these do on this list of numbers. So if we look at the built-in, so built into Python, no libraries needed. We have a sum, a min, and a max function. All right. So for now, I'm just going to show you what each one of those do. So remember, I've got my numbers in memory. If you pass a list of numbers to the sum function that's built into Python, what it will do is it will take each of those elements of that list that you passed, and assuming that they are numeric, I'm sure if you put a string in that sequence, it's going to complain a little bit. But in our case, we have integers, so this is good, and we have the integers 1, 2, 3, and 4. So 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. So when we pass that list to sum, we get back that sum 10. All right. If instead of sum we use min, it's going to return the smallest element, the smallest valued element, I should say, in that collection that you pass. So in this case, we pass this list of numbers, 1, 2, 3, 4. So the minimum is 1. And then, of course, the maximum, as you might expect, is going to be the opposite. It's going to give you the largest valued item in that list. All right. So let's say that we've got these numbers and we've got our functions. So now what we can actually do, instead of looping over my numbers or something like that, we can actually loop over these functions. All right. So I could say something like for function in my functions. All right, and I'm going to print something. I'm going to use the F string here. And I'm actually first going to print out the function. So I'm just going to say, what is that function? And then I'm going to print an arrow and print what this function applied to that list of my numbers returns. So I'm going to say function. Now this one's interesting. Let me get my braces right here. And this might be a little bit tricky to understand, but let me get this typed in and then I will go back and explain it. All right, first off, let's see if this runs. Let me put an equal sign there. All right, great. All right, so we had our functions. We got the sum, the minimum, or the min, and the max functions. And then I'm saying for function in my functions. And then what I'm doing is I'm printing out first. I'm just printing what the function is, what it's actually calling. And then this is the part right here that's really, really interesting, right? And again, it's a subtle thing, but this is really powerful. And this is not something that you can do in all languages. So in Python, functions are first-class citizens. We can pass them to other functions. We can use them, like in this case, in a list, and we can, kind of iterate over those and use those functions. But the neat thing is this. So notice in our functions, we've got 3 different functions, the sum, min, and the max. Now remember, when we've got a for loop, we're passing it something that can be iterated over. So in this case, my functions is a list right here. We've defined it as a list. And for each one of those items, it's assigning that to this looping variable, which we've called function. Okay. So in this case, we're think about what happens in the first step of that loop. When we go through my functions, well, the first thing that we encounter is sum, right? So what it does is it takes sum and it essentially stores that in this looping variable function. So now function, when we call it right here, we're actually just calling the sum function, right? Because we've stored that in this temporary variable. All right, next step through, we're going to the min. All right, so the next thing that's encountered is the min. That gets stored in the temporary variable. So when we call function, we're actually calling the min. And we can see that right here, right? So when I'm printing out the function, well, the first time it's the sum, second time it's the min, then it's the max. And we can see that just by calling function my numbers, right, we're able to access each one of those, right? So that's really kind of an interesting and unique thing that I use a lot, actually, when you kind of realize the power and the flexibility that gives you. It's a really, really nice feature that's available to you in the Python language. All right, let's look at a few other types of iterable objects. First, let's look at a set, right? So this is going to be pretty straightforward. So if we have a set here, so I can just define my set. So if you remember, a set just stores, it's essentially a container of unique items, right? So the way that we define a set is just open and close curly brace, very similar to a dictionary, except we don't have key value pairs. We just have elements like we would in a list. So I'm going to put in some names. So Alice, Bob, and Carl. All right, so that's my set. And again, just to really drive that point home, that sets require elements to be unique. What would happen if I were to put Bob in that set twice? All right, it's only going to include one of those because the elements of a set have to be unique. All right, so what we could do is we could say, well, for name in my set, I'm going to print name. All right. So at this point, I actually realized that I should have earlier on probably emphasized one other very, very important thing that you've now seen a few times. You might be wondering why it's happening, but I should have probably mentioned it right from the onset of this. And that is, notice that whenever I'm making these for loops, I'll do like a for number in range, and then you put this colon at the end. That's basically saying, okay, well, this is the end of the for statement. Whenever I hit enter, right, it's essentially nesting, right? So there's some white space at the beginning of the statement. And that's very, very important. That's actually critical in Python. So you see it every time that we've done a for loop. When I've hit enter and put that next statement there, it's essentially nested that next line by 4 spaces, actually. So if I were to look at this, here's my cursor, watch it. So 1, 2, 3, 4. All right. Or you can use a tab as well. I actually prefer tabs because it's fewer keystrokes. And what this is doing is, this is how Python indicates hierarchy. All right. Now, if you've never, done any programming in any other type of language, maybe this seems like, well, yeah, that makes a whole lot of sense. But this is not the case in a lot of other languages. A lot of other languages, think like a C or C++, they actually use curly braces to indicate hierarchy. All right, just to give you an example of what that might look like, it would be like something like, okay, well, for name in my set, and then you might have, an open type of parenthesis here. And of course, their functions, or not an open parenthesis, but like some type of a curly brace. And their syntax looks a lot different. So this is not, valid C++ or C code, but they use curly braces, and basically it's saying, okay, well, for each one of these items, what do I want to do? Well, whatever is in those curly braces, and it allows you to write your essentially the logic that you want to apply on that line. All right, well, in Python, white space is what dictates that hierarchy. All right, so for each name in this set, what we want to do is we want to print the name. Right, so notice if I were to unindent here, so just put the print statement right under the for, it's going to say, hey, I expected an indented block after the for statement. So right now we're telling it, well, for each one of these names in my set, and it expects us to have something that we're going to do with each one of those names. All right. So right now, since we've moved that print statement out, it's essentially indented at the same level as the for. The Python doesn't know that we're wanting to print the name for each one of those. So we have to have that indent there. And that's Python using white space to indicate this hierarchy. It's saying, oh, now I recognize that for each one of those names, you actually want to print those names. Okay. So white space is important. All right. White space is critical. And you can actually have, continue this indentation for more complicated flow control, which we'll see some examples of that by the time we get done with these videos on flow control. All right. So up to this point, we've looked at just a basic for on a range. We've iterated over items in a list, and we have iterated over items in a set. All right, let's look at dictionaries really quick, and then I'm going to go back and show you just a few special cases, but I'll probably do those in another video. So let's finish out this video looking at, kind of looping over the core types in Python, which I would consider to be, or at least the core type of containers, which would be like a list and a set and a dictionary. All right, so I'm going to define a dictionary of Major League Baseball teams. This is not going to be all of them. So I'm going to do MLB teams. Well, let's make us a dictionary here. So remember, dictionaries we define with open close curly braces, and we've got to have key value pairs. So I'm going to do the Colorado Rockies. All right, let's do the Boston Red Sox. Let's do the Minnesota Twins. And that should be enough. Awesome. Very good. So we've got a dictionary here for a few locations and their corresponding Major League Baseball team. All right. Now, if you remember, so MLB teams, if I were to look at the type of this, all right, so that is a dictionary. All right. If you recall, dictionaries have keys, right? So those are the items here. So your keys. They also have values, right, which we can access with this values method. So that's our Rockies, Red Sox, and Twins. And then they also have items. All right, and if you recall, items are actually returning tuples, right? So they're returning keys and values as a pair, essentially as a tuple, right? So two elements in there, right? Even though a tuple can be more than two elements. So don't kind of try to associate the fact that it's got two elements with what's called a tuple, right? So tuples can have, you can have tuples with 3 or more elements in there. But in this case, we've got 2 because it's returning key value pairs. All right. So we've seen dictionaries have keys, values, and items, and we can iterate over all of those, right? So actually dictionaries are iterable in Python. So we could say for, location in MLB teams.keys, right? And then if we wanted to get the team that was associated with each one of those locations, if you recall, when we've got a dictionary and we want to check or get the value for a key, I'm going to say get for location. That should give me back the team's name. So I'm going to say this is going to be the team name. And what we'll do is we will print F, and let's print the location. And let's print the team name. All right, so we got the Colorado Rockies, the Boston Red Sox, and the Minnesota Twins. All right, now again, just remember, just a few things as kind of a refresher, right? So if I've got MLB teams, that's a dictionary. We could have done something like this. If I had the key Colorado, I can get that value. Okay, but what if we were looking at another list and we were trying to see, well, does this location have a team, right? So maybe our location, instead of it being one that was in there, so let me just revise this a little bit. Instead of hard coding that in, I'm going to make a variable called location, set that equal to Colorado, and say, well, get that. All right, well, what if we were looking at, I don't know, Birmingham? That's not in our dictionary. So when I try to access that or request the value for that key in our dictionary, we get an error. It's going to say, hey, there's no key called Birmingham, so it returns a key error. All right. Now, so we could have done it like this, and we could see that if we ever run into a situation in our program where we're requesting a key that doesn't exist in that dictionary, we're going to end up with an error. So that's why I like to use this get. All right, because if you recall, get has a default value. By default, it's none. So it returns the value for the key if it's in the dictionary. Otherwise, it returns the default value, which is none. So the good thing about this is if I run this, we don't get anything back, which is expected, right? Because that team is not in that dictionary, or that location is not, but we don't get an error. It allows our program to continue running. All right. And now if I go and put Colorado, now we get the Rockies. All right. Now, if we went back and put Birmingham, and in this case, it's actually returning none. So if I were to store this as a temporary variable, just underscore. So notice that that underscore is actually a valid variable name. And this is oftentimes used when we're just trying to create a temporary variable. If I look at underscore, right, I can print that. If I look at the type of it, that's a none type. Okay, so it's returning none. All right. So a little bit of a detour right there, but thought that was kind of good refresher material. So we looked at, we can iterate through keys. One thing I do want to add is if you just need to go through the keys in a dictionary, you actually don't have to do keys. You can just do something like this. So I'm going to just copy this code right below. And instead of .keys, I'm just going to say for location in MLB teams, and we're going to get exactly the same result. So by default, if you're just saying for, loop variable in a dictionary, it's by default just going to iterate over the keys. All right. Now, again, notice that in this case, I've got in the previous examples when I was using the for loop, I was just essentially doing for something in print, right? So we had that nesting. I kind of talked about that. That white space indicated hierarchy there, and what needs to happen for each iteration or step of that loop. Notice now for each one of those locations, we're actually getting the value, and then we're printing both the location, which was the key, and the team name, which is essentially the value that we retrieve for that key. All right, so notice I've got two things that I'm doing. I'm getting a value and then I'm printing, right? Both of those have to be nested, right? Because these are both things that we're doing in each step of that loop. Watch what happens if I were to move that print back. All right, so for each location, we get the team name, and then when I hit print, it only prints the Minnesota Twins. Why? Because it's the nesting. So since this print is outside, what it does is it's looping through each one of those. It's getting that team name. So it goes through 4 location. The first one, Colorado Rockies, Boston, Minnesota. And then it's just assigning that, but it's not printing. So the print's not happening in each one of those iteration or each one of those steps of the for loop. And why does it print Minnesota Twins? Because that's the last thing that it encounters. So right now, location, so it went 4 location in MLB teams. First time it assigned Colorado. Then it assigned Boston. Then it assigned Minnesota. And then it exited because that's all the entries that were in that dictionary. So at the end of that loop, location has the value of Minnesota, and also the team name, since the last location was Minnesota, is going to have the Twins, and that's what gets printed. But it's not printing for each one. So if we want to make sure that we're printing each one of those as we go, we've got to make sure that that is nested under so that it understands that hierarchy. All right. And that is, another thing that is important to kind of note here. So at the end of this, so location, once you're doing this iteration and you're going through this looping structure, so location is now defined in your program, right? So now I can call location out here, and it's going to include, or it's going to contain the last value that it was pointed to in that loop. All right. So that's just one thing to kind of note, right? Because what if I had a variable outside of my program, right? Or let's say that, somewhere in my program I have location is Birmingham. Okay. And that's supposed to be, just stay at that. I want it to be Birmingham always. But then I end up using the same variable name in my loop. All right. Well, what you're going to do is, let's say that this value is important and you think it should always be Birmingham, but you ended up using the same looping variable name. Okay. So for location in this, well, at the end of this, location is not Birmingham anymore. It's Minnesota because you use the same variable name. So you have to be careful with that. So one thing that a lot of people do, they don't, that at least I see, is people tend to, want to minimize their keystrokes. And they might give things, very non-informative names, or just something really short, like maybe X, right? So for X, and you can end up getting into a lot of trouble right here. So in this case, I've got to change my looping variable. Because no, this is printing Minnesota Twins. Why? Because location was defined from that previous run of that cell. So let me update that to be X, right? So in this case, to me, it's a lot easier to kind of, mess things up, because if you're not giving your variables non-informative names, you're using things over, kind of reusing a lot in your code, which I know I do that a lot when I'm doing these videos, but it's just because we're doing short demonstrations. But once we start building full programs out, we'll be very careful about our naming conventions, and making sure that we have informative names, and that we're, when we're using loops, we're not overriding variables that we have defined elsewhere. All right, because that can lead to bugs. And in that case, you're not going to know, right? There's no error coming out of this. So you thought X was supposed to be Birmingham, but you used X in your loop. And all of a sudden you've got a bug in your program, and it's not going to be giving you the results that you think it should. All right, so that's where I'm going to stop this video. So we looked at, or actually, no, I've got just a few other things. So I got a little bit carried away there. All right, so we did keys. Okay, so let's look, in addition to keys, let's look at values and items. Okay, so here's our MLB teams dictionary. All right, so up to this point, we've seen that we can kind of loop over. Let me kind of just clean the slate just a little bit, because we took a few little detours there. All right, so I just restarted the kernel, and I'm going to run from top to bottom just to make sure Everything is what I want. I'm going to change this back to location. Awesome. All right, so everything's good. All right, so we saw that we could use keys, and then in this code cell, we basically saw that we don't need to use keys because if we're just trying to loop over the key with a dictionary, by default, you're going to be getting the keys back. All right, you can also loop over the values. So you could say for, now think about the values in our MLB teams dictionary, that's going to be the team names. I'll say something like for team name in MLB teams dot values. And then what we'll do, I'm just going to print the team name. So this is, I do iterate over values in some cases. There are cases where this is, definitely, the right thing, the thing that you need to do. But a lot of times when you're working with dictionaries, again, it's key value pairs. So you might not just care about the value, but also the key. So the nice thing is if you iterate over keys, you can always use the .get and you can grab the value back. So we're able to print the location and the team name. But when we're doing the values, we're not really going to be able to do that. All right, because there's no way, there is a way, but it typically means or requires creating kind of a mirror copy of your dictionary. At least that's the way that I tend to do it, where you could go back and get the key that corresponds to a value. But in this case, it's really kind of complicated without creating additional objects to go from the value, in this case, the team name, and say what location gave us that. All right. However, this last method, you kind of get the best of both, right? So to me, this is kind of, one of the more efficient ways to do things. So if you notice, what were some of the challenges? So when we're looping through the keys, right, either using the method where we actually called out keys or just using the dictionary, well, we had to have an additional line here where we said, okay, well, now look up the value for that key. And then when we did the values, the problem was, well, we didn't have an easy, quick way of going back and saying, well, what location corresponds to this team? All right. Well, recall, we got a dictionary, we've got items. All right. So this is returning those tuples. All right. So key value pairs. And we can iterate over this. So what we can do is we can say for, and I'm going to say location and the team name in those items. And then now I'm just going to print my statement. We get this all copied in. And we'll say location. And then team name. All right, so the nice thing about this is we don't have to do this extra assignment like we did when we were getting just the keys, and then when we were getting the values we couldn't get the location. When we loop through the items, we get back the key value pairs, and the only thing that's kind of different is notice right here we're using multiple assignment. We know that this is returning two things, right? So MLB teams, if I look at the items, it's returning essentially this iterable object of tuples. So Colorado and Rockies is the first pair, Boston and Red Sox is the next pair. Minnesota and Twins is the next pair. So it's returning two things at a time. So I have to have two variable names, so location and team name. So for each one of those items, so in this case, at each step through this loop, it's returning two things. And I'm saying take the first thing in that tuple and store that in the location variable, and take the second thing and store it in the team name variable. So we're doing this assignment of two elements here at a time, and then I can immediately just print out the values of those loop variables, and we get them both. So in this case, this is a nice efficient way of essentially getting both of those where we don't have to go and get this extra assignment. Now, as you can imagine, right, there could be data structures where instead of returning two things at a time, it's returning three things at a time, or it's some type of a nested structure. And all of this applies as long as you know what is being returned and how many items are being returned from the object that you're iterating over. Okay, well, you just use that to figure out how many variables you need, and then do we need to do additional logic down here to kind of help with that. Let me just show you one example of that, just to make that super crystal clear. So I'm going to copy my MLB teams dictionary down here. All right. And let's say that this is going to be now, let's say that we had defined it like this. Instead of just having key value with the team name, let's say that we had like a nested dictionary structure. And maybe this would be flexible enough that in the future, maybe we want to put additional information for each one of those locations, like, what was the year that the team was founded, or whatnot. But let's say for now, I'm just creating a nested dictionary structure. Now I'll show you what this looks like. All right. So now if I look at MLB teams, if I look at the type of this, all right, it's a dictionary. And if I were to grab the item, so I'm going to do MLB teams get, and let's get Colorado. All right, notice what it returns. So it was returning values, and this is indeed the value for that key in that dictionary, but what is the type of the thing that's being returned? Well, it's actually a dictionary itself. All right, so this thing is returning dictionaries. All right, so now if I were to run this same loop, right, with our newly defined MLB teams object, so let me just make sure that's in memory. All right, notice now it's doing Colorado, and instead of just nicely printing the name, it's printing that entire dictionary. Why? Because that dictionary is the value, right? That's the correct thing. Well, what if we only care about the name attribute? And I'm just going to put some other attributes here. Let's say age, and I'm just going to make up some numbers because I have no clue how old these teams are. So let's just say 80. And then let's say the Twins. I've got some extra commas in there. All right, let's just say 45. I don't know. Let me make sure this is a valid. Yep. So now if I did MLB teams.get Colorado. Yep. So now we've got a dictionary that has its name and its age. All right. All right, so now, again, those are valid values, but what if we don't want to print it as such? What if we want to get the age and then we want to get, maybe the name? Well, this is where we would have to know what's the thing that's being returned, what's the type of that, how do I interact with it to get the elements that we need to grab for our particular use case. All right, so if this case, right, maybe we want to get the team name. And let's think about this, actually. All right, so the item that it's returning, so it's giving us a location and it's giving us the team. It's not the team name. It's giving us a dictionary of team information. So I'm going to name this second variable team info. All right, let's just print it as is. All right, so it's just that dictionary. So if I look at what's currently stored in team info at the end of that loop, it's just that inner dictionary for the Minnesota Twins. All right, well, that's helpful. So what we can do then is we can say, okay, well, let's get the age. So the age, where would the age be stored? Well, it's in team info, this inner dictionary, in the age key. So I could say team info because remember, that's a dictionary that's returned to us because the values are dictionaries. I know it gets a little bit confusing. But team info, as we've seen, it's a dictionary. So I want to get the age key. So I'll do a .get, and I'll get that age key. And then we'll get the name. And that's going to be team info, which is that loop variable which contains a dictionary. Get name. All right. And I'm going to say location, name, or age years old. And let me take out my, let's see, location, and I need to get the team name instead of team info. And there we go. All right, so now I will conclude this video since we've looked at kind of those core container structures and iterating over them. So in particular, we looked at lists, we looked at sets, we looked at dictionaries. We've talked a lot about different subtleties, including the need for white space to indicate hierarchy and so forth. So We will continue on looking at flow control in a future video. We're going to show you a lot of different things, but first up we'll be looking at enumerate and zip, which will help us iterate over pairs of list, or to get information about the index of items in a list.